Question 1. The efficiency study reveals that the virtual machine provisioning process is experiencing significant delays, impacting the ability to deploy new services within acceptable timeframes. The current vSphere environment consists of multiple XC hosts, a shared storage array, and vCenter server managing the cluster. The delays appear to be most pronounced during the disk cloning and VM startup phases of provisioning. What is the most effective approach to diagnose and resolve the virtual machine provisioning bottleneck? Option A. Analyze vSphere performance metrics for CPU, memory, disk I/O, and network utilization on XC hosts and the storage array during provisioning operations to identify resource contention. Option B. Immediately upgrade all XC hosts to the latest version and reconfigure the vSphere distributed switch settings to the newest available profile. Option C. Initiate a full vMotion of all virtual machines to a different, less utilized cluster to alleviate load on the current infrastructure. Option D. Manually adjust the advanced storage settings on individual XC hosts without first establishing a baseline or understanding the current configuration. Correct answer is A. Analyze vSphere performance metrics for CPU, memory, disk I/O, and network utilization on XC hosts, and the storage array during provisioning operations to identify resource contention. Explanation. The efficiency study reveals a significant bottleneck in the virtual machine provisioning process, leading to extended deployment times and increased operational costs. This scenario is professionally challenging because it requires a deep understanding of VMware vSphere architecture, specifically the interaction between vCenter server, XC hosts, and storage, to identify and resolve performance issues without disrupting ongoing operations or compromising data integrity. Careful judgment is required to balance the need for rapid improvement with the inherent risks of modifying a production environment. The correct approach represents best professional practice because it prioritizes a systematic, data-driven investigation of the identified bottleneck. By leveraging vSphere's built-in performance monitoring tools and analyzing resource utilization metrics, CPU, memory, disk I/O network, the administrator can pinpoint the root cause of the provisioning delay. Implementing targeted optimizations, such as adjusting storage I/O control settings, optimizing VM disk formats, or reconfiguring network adapters, directly addresses the identified performance issue. This method aligns with professional standards of proactive system management and continuous improvement, ensuring that changes are based on evidence and have a predictable impact. An incorrect approach that involves randomly reconfiguring vSphere cluster settings without a clear hypothesis or baseline data is professionally unacceptable. This action lacks a systematic diagnostic process and introduces unnecessary risk. It could lead to unintended consequences, such as performance degradation in other areas, increased host contention, or even service outages, violating the principle of least privilege and responsible system administration. Furthermore, making changes without proper documentation or rollback plans constitutes a failure in change management best practices. Another incorrect approach, such as immediately migrating all virtual machines to a new, unproven hardware platform without thorough testing and validation, is also professionally unsound. This bypasses critical performance benchmarking and compatibility checks, potentially leading to unforeseen issues with application performance, driver compatibility, or storage access. It demonstrates a lack of due diligence and a disregard for the stability of the production environment. The professional reasoning process for similar situations should involve a structured problem-solving methodology. This includes clearly defining the problem, gathering relevant data through monitoring and logging, forming hypotheses about potential causes, testing these hypotheses through controlled experiments or targeted changes, and validating the results. Documenting all steps, changes, and outcomes is crucial for accountability and future reference. A risk assessment should be performed before implementing any changes, and rollback plans should be in place to mitigate potential negative impacts. Question 2. Implementation of a critical security patch for a widely used virtualization component has been announced, addressing a vulnerability that could allow unauthorized access to virtual machine data. The administrator has downloaded the patch but has not yet tested it in a lab environment. The organization's change control policy requires a minimum of 48 hours of testing in a non-production environment before applying any patches to production systems. However, The vendor's advisory indicates that the vulnerability is actively being exploited in the wild, and the potential impact on the organization could be severe if exploited. The administrator is under pressure from management to ensure immediate protection. Which of the following actions best represents the most responsible and ethical approach for the virtualization administrator? Option A. Immediately deploy the patch to all production virtual machines to mitigate the immediate threat, documenting the decision as an emergency exception to the change control policy. Option B. Apply the patch to a small subset of non-critical production virtual machines first, bypassing the lab testing requirement to expedite the rollout. Option C. Publicly disclose the details of the vulnerability and the patch to the wider IT community to encourage rapid development of alternative solutions. Option D. Proceed with testing the patch in a lab environment as per the change control policy, while simultaneously informing management of the active exploitation and the potential risks of delaying the patch. Correct answer is A. Immediately deploy the patch to all production virtual machines to mitigate the immediate threat, documenting the decision as an emergency exception to the change control policy. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in the ethical obligation to maintain data integrity and security within a virtualized environment, while also adhering to the principle of least privilege. The administrator is aware of a potential vulnerability that, if exploited, could lead to unauthorized access and data compromise. The pressure to maintain service availability and the potential for negative business impact if the vulnerability is widely publicized or exploited adds to the complexity. A hasty or uninformed decision could have significant repercussions. Correct approach analysis. The correct approach involves a systematic and documented process of vulnerability assessment, risk analysis, and controlled remediation. This aligns with best practices in IT security and data governance, emphasizing proactive measures and informed decision-making. Specifically, it adheres to the principle of responsible disclosure and the need for thorough testing before implementing changes that could impact production systems. This approach ensures that the fix is effective, does not introduce new issues, and is implemented with minimal disruption, thereby upholding professional responsibility and safeguarding the integrity of the virtualized infrastructure. Incorrect approach is analysis. One incorrect approach involves immediately applying the patch to all production systems without prior testing. This violates the principle of least privilege and introduces significant risk. Without testing, the patch could be unstable, cause performance degradation, or even lead to system outages, directly contradicting the administrator's duty to maintain a stable and secure environment. This approach also bypasses necessary change control procedures, which are critical for accountability and rollback capabilities. Another incorrect approach is to ignore the vulnerability due to the perceived low risk or the inconvenience of patching. This is a direct ethical failure, as it neglects the administrator's responsibility to protect the organization's data and systems from known threats. It demonstrates a lack of due diligence and could lead to severe security breaches, data loss, and reputational damage, all of which are preventable through responsible action. A third incorrect approach is to disclose the vulnerability publicly without first attempting to remediate it or notifying the vendor. This action could alert malicious actors to the exploit, increasing the likelihood of it being used against the organization before a fix is available. This is an irresponsible disclosure that prioritizes sensationalism over security and professional duty. Professional reasoning. Professionals in virtualization environments must adopt a risk-based approach to security. This involves understanding potential threats, assessing their impact, and implementing controls to mitigate them. Decision-making should be guided by established IT security frameworks and organizational policies. When faced with a vulnerability, the process should involve 1. Identification and verification of the vulnerability. 2. Assessment of the risk and potential impact. 3. Researching and testing available solutions, e.g., patches. 4. Planning and scheduling the remediation with appropriate change control. 5. Implementing the solution in a controlled manner, ideally in a test environment first. 6. Verifying the effectiveness of the fix and monitoring for any adverse effects. This structured approach ensures that decisions are informed, risks are managed, and the integrity and security of the virtualized environment are maintained. Question 3. Stakeholder feedback indicates a critical business application is experiencing intermittent performance degradation, and a specific stakeholder, who is a key user of this application, has requested an immediate, direct modification to a virtual machine's network adapter settings to resolve the issue, believing it to be the sole cause. Option A. Directly implement a different, unrequested configuration change on the virtual machine that the administrator believes might be a more likely cause of performance issues, without stakeholder consultation or formal approval. Option B. Document the stakeholder's request and the perceived issue, then schedule a comprehensive performance analysis of the virtual machine and its environment, followed by a formal change request process for any necessary modifications. Option C. Implement the requested network adapter change immediately on the virtual machine, as the stakeholder is a key user and the request is specific. Option D. Inform the stakeholder that their request cannot be fulfilled due to policy, without further explanation or offering alternative solutions. The correct answer is C. Implement the requested network adapter change immediately on the virtual machine, as the stakeholder is a key user and the request is specific. Explanation. This scenario presents a professional challenge due to the conflict between a stakeholder's desire for immediate, potentially unverified system changes and the VMware administrator's responsibility to maintain system integrity, performance, and compliance with established operational procedures and VMware best practices. The administrator must balance stakeholder satisfaction with their duty to ensure the virtualization environment remains stable, secure, and efficient. The correct approach involves a structured, documented process that prioritizes risk assessment and validation before implementing changes. This aligns with the principles of IT governance and operational excellence, which are implicitly expected in a professional VMware environment. Specifically, it upholds the ethical obligation to act in the best interest of the organization's IT infrastructure, preventing potential disruptions or security vulnerabilities. This approach ensures that any changes are understood, approved, and implemented in a controlled manner, minimizing the risk of negative impact. An incorrect approach that bypasses standard change control and validation procedures, such as directly implementing the requested change without proper testing or approval, represents a significant regulatory and ethical failure. This could lead to system instability, data corruption, or security breaches, violating the administrator's duty of care. Another incorrect approach, such as outright refusing the request without offering alternatives or explaining the rationale, demonstrates poor stakeholder management and a lack of collaborative problem-solving, which, while not a direct regulatory violation, is professionally deficient and can erode trust. Finally, an approach that involves making a quick, undocumented change to appease the stakeholder, even if it appears to work initially, is ethically unsound as it introduces hidden risks and undermines the integrity of the IT environment and audit trails. Professionals should employ a decision-making framework that includes understanding the request and its potential impact, consulting relevant policies and procedures, e.g., change management, security policies, performing a risk assessment, communicating transparently with stakeholders about the process and potential outcomes, and documenting all actions taken. This systematic approach ensures that decisions are informed, justifiable, and aligned with professional responsibilities and organizational objectives. Question 4. The monitoring system demonstrates a consistent pattern of unusual network traffic originating from a specific virtual machine within a production environment during off-peak hours. The virtual machine is not scheduled for any maintenance or updates. As the lead virtualization engineer, you suspect a potential security compromise or unauthorized activity. What is the most appropriate course of action? Option A. Document the observed traffic patterns, consult the organization's incident response plan, and escalate the findings to the Security Operations Center, SOC, for further analysis and guidance. Option B. Ignore the traffic alerts, assuming they are transient network anomalies, and focus on planned infrastructure upgrades. Option C. Immediately isolate the suspect virtual machine from the network and initiate a forensic investigation without notifying management. Option D. Attempt to remotely access the virtual machine and review its running processes and logs to identify the source of the traffic, hoping to resolve it quickly before it impacts production. Correct answer is C. Immediately isolate the suspect virtual machine from the network and initiate a forensic investigation without notifying management. Explanation. The monitoring system demonstrates a recurring pattern of performance degradation in a critical production virtual machine cluster during peak business hours. This scenario is professionally challenging because it involves balancing the immediate need for system stability and user access with the potential implications of unauthorized access or data manipulation. The IT administrator is faced with a situation where a security vulnerability might be exploited, but investigating it without proper authorization could lead to further disruption or violate established protocols. The correct approach involves escalating the issue through the established incident response and change management procedures. This ensures that any investigation or remediation is documented, authorized, and executed by the appropriate personnel, minimizing the risk of unintended consequences or security breaches. This aligns with best professional practices by adhering to the principle of least privilege and maintaining a secure, auditable system. Specifically, in a regulated environment, this approach upholds the integrity of data and systems, as mandated by general IT governance principles that emphasize controlled access and authorized actions. An incorrect approach would be to directly access and modify the virtual machine's configuration or network settings without prior authorization or a documented change request. This bypasses established security protocols and could inadvertently introduce new vulnerabilities or disrupt services further. Such an action would represent a significant regulatory and ethical failure by violating the principle of accountability and potentially breaching data privacy or security policies. Another incorrect approach would be to ignore the alerts, assuming they are false positives, without proper investigation. This failure to act on potential security threats is a direct contravention of duty of care and could lead to severe security incidents, data loss, or compliance violations. Professionals should employ a structured decision-making process that prioritizes adherence to established policies and procedures. This involves 1. Recognizing and documenting the anomaly. 2. Consulting incident response plans and change management policies. 3. Escalating the issue to the appropriate team or management for authorization and guidance. 4. Implementing approved solutions in a controlled and documented manner. This systematic approach ensures that all actions are justifiable, secure, and compliant with organizational and potentially regulatory requirements. Question 5. Benchmark analysis indicates that several critical virtual machines are experiencing intermittent performance degradation, impacting application responsiveness. The virtualization administrator needs to address this issue efficiently and effectively. Which of the following approaches best aligns with optimizing process and ensuring minimal disruption? Option A. Immediately increase the allocated CPU and memory resources for all virtual machines within the affected cluster to preemptively address potential resource starvation. Option B. Focus exclusively on analyzing network traffic patterns and latency for the affected virtual machines, assuming network congestion is the primary cause of the performance issues. Option C. Systematically collect performance metrics from the affected virtual machines and their underlying infrastructure. Establish a baseline, identify specific deviations, and correlate these deviations with potential resource contention or configuration issues before proposing targeted remediation. Option D. Roll back the virtualization environment to the last known stable configuration without further investigation to quickly restore perceived performance. The correct answer is C. Systematically collect performance metrics from the affected virtual machines and their underlying infrastructure, establish a baseline, identify specific deviations, and correlate these deviations with potential resource contention or configuration issues before proposing targeted remediation. Explanation. Scenario analysis. This scenario presents a common challenge in data center virtualization environments where performance bottlenecks can impact critical business operations. The challenge lies in accurately identifying the root cause of performance degradation without disrupting ongoing services or introducing new issues. A hasty or misinformed approach can lead to wasted resources, extended downtime, and potential compliance violations if service-level agreements (SLAs) are breached. The need for a systematic, data-driven approach is paramount. Correct approach analysis. The correct approach involves a phased, methodical investigation that prioritizes data collection and analysis before implementing changes. This aligns with best practices for IT service management and operational efficiency. By first establishing a baseline, then identifying specific metrics that deviate from this baseline, and finally correlating these deviations with potential causes, a precise diagnosis can be made. This data-driven methodology ensures that any proposed solutions are targeted and effective, minimizing the risk of unintended consequences. This approach also supports auditability, as the steps taken and the data collected provide a clear record of the troubleshooting process, which is crucial for demonstrating due diligence and adherence to operational standards. Incorrect approaches analysis, implementing broad, unverified changes without a clear understanding of the problem, is a significant regulatory and ethical failure. For instance, indiscriminately increasing resource allocations across all virtual machines, VM, without identifying the specific VMs or resources experiencing contention is wasteful and can mask underlying issues, potentially leading to future performance problems or increased operational costs. This approach lacks the rigor required to meet operational efficiency standards and could violate cost management policies. Another incorrect approach is to immediately revert to a previous, known good configuration without thorough analysis. While seemingly safe, this ignores the possibility that the issue is new or has evolved, and reverting without understanding the cause prevents learning and improvement, potentially leaving a critical vulnerability unaddressed. This failure to investigate and resolve the root cause can lead to repeated incidents and a breach of operational stability requirements. Finally, focusing solely on network performance when the symptoms point to storage I/O contention is a misdirection. This leads to wasted effort and time, delaying the resolution of the actual problem, and potentially causing a breach of SLAs due to prolonged performance degradation. This demonstrates a failure in diagnostic methodology and resource allocation, which are key components of operational excellence. Professional reasoning. Professionals should adopt a structured problem-solving framework. This begins with clearly defining the problem and its impact. Next, gather relevant data, including performance metrics, logs, and configuration details. Analyze this data to establish a baseline and identify deviations. Formulate hypotheses about the root cause and test them systematically, prioritizing non-disruptive methods. Implement changes incrementally and monitor their impact. Document all steps, findings, and resolutions. This approach ensures that solutions are effective, efficient, and auditable, upholding professional standards and regulatory compliance. Question 6. Investigation of a virtualized data center environment reveals consistently high CPU utilization on several hosts, leading to occasional performance degradation for critical applications. The IT team has been manually migrating virtual machines to other hosts when alerts are triggered, a reactive and time-consuming process. What is the most effective approach to optimize resource utilization and proactively address this performance issue? Option A. Manually reconfigure the CPU allocation for all virtual machines to a lower setting to reduce overall demand. Option B. Ignore the alerts and focus on troubleshooting individual VM performance issues as they arise. Option C. Implement dynamic resource scheduling and affinity rules to intelligently balance workloads across hosts and ensure critical VMs have dedicated resources. Option D. Increase the number of physical hosts in the cluster to distribute the load more broadly. The correct answer is C. Implement dynamic resource scheduling and affinity rules to intelligently balance workloads across hosts and ensure critical VMs have dedicated resources. Explanation. This scenario presents a common challenge in data center virtualization, optimizing resource utilization without compromising performance or availability. The challenge lies in balancing the dynamic nature of virtualized workloads with the need for predictable and efficient infrastructure. Professionals must consider not only the technical aspects of resource allocation, but also the potential impact on service-level agreements, SLAs, and operational costs. The regulatory framework for this exam, VMware Certified Professional 6 Data Center Virtualization Delta, focuses on the technical implementation and operational best practices within the VMware ecosystem. While not explicitly a regulatory body, adherence to VMware's documented best practices and the principles of efficient data center management are paramount for professional competence and certification. The correct approach involves a proactive and data-driven strategy for resource optimization. This includes continuous monitoring of resource consumption, identifying underutilized or overutilized resources, and implementing intelligent workload placement and resource allocation policies. This aligns with best practices for efficient data center operations, aiming to reduce operational expenditure through optimized hardware usage and improved performance through better resource distribution. By leveraging VMware's built-in tools and understanding workload behavior, professionals can make informed decisions that enhance the overall efficiency and cost-effectiveness of the virtualized environment. Incorrect approaches often stem from reactive measures, guesswork, or a lack of understanding of workload dependencies. Implementing broad, indiscriminate resource capping without proper analysis can lead to performance degradation for critical applications, violating implicit SLAs and potentially impacting business operations. Similarly, simply over-provisioning resources to avoid potential issues is inefficient and costly, failing to meet the optimization objective. Ignoring performance metrics or relying solely on anecdotal evidence for resource adjustments can lead to suboptimal configurations, increased technical debt, and a failure to meet the core requirements of process optimization. These approaches demonstrate a lack of due diligence and a failure to apply systematic problem-solving techniques, which are essential for professional data center management. The professional decision-making process should involve a cyclical approach: monitor, analyze, plan, implement, and reevaluate. Professionals should first establish baseline performance metrics and resource utilization patterns. Then, they should analyze this data to identify specific areas for optimization. Based on this analysis, a targeted plan should be developed, considering the potential impact on all virtual machines and services. Implementation should be carefully managed, with rollback plans in place. Finally, the impact of the changes must be continuously monitored and reevaluated to ensure ongoing optimization and to adapt to changing workload demands. Question 7. What factors determine the most effective strategy for optimizing resource allocation and performance within a VMware vSphere environment? Option A: implementing performance tuning based on user complaints and isolated system alerts without a broader data analysis. Option B: a singular focus on acquiring the latest hardware upgrades to ensure maximum processing power for all virtual machines. Option C: aggressively reducing the number of virtual machines and consolidating workloads onto fewer hosts to minimize licensing costs. Option D: comprehensive analysis of current resource utilization, workload patterns, and performance metrics, coupled with the strategic application of automated resource management tools. The correct answer is D: comprehensive analysis of current resource utilization, workload patterns, and performance metrics, coupled with the strategic application of automated resource management tools. Explanation: scenario analysis. This scenario presents a common challenge in data center virtualization: optimizing resource utilization and performance without compromising service availability or incurring unnecessary costs. The pressure to deliver high-performance virtualized environments while adhering to budget constraints and operational efficiency mandates careful consideration of process optimization strategies. The complexity arises from the interconnectedness of virtual machines, underlying hardware, and network infrastructure, where a change in one area can have cascading effects on others. Professionals must balance technical feasibility with business objectives and regulatory compliance, making judgment calls that impact operational stability and cost-effectiveness. Correct approach analysis. The correct approach involves a holistic review of the virtual infrastructure's performance metrics, resource allocation, and workload patterns. This includes analyzing CPU, memory, storage, and network utilization across the virtual environment. Identifying underutilized resources allows for consolidation, while overutilized resources signal the need for optimization or scaling. Implementing automated resource management tools, such as VMware's vRealize operations or similar solutions, can provide real-time insights and facilitate proactive adjustments. This approach aligns with best practices for operational efficiency and cost management, ensuring that resources are allocated effectively to meet application demands without over-provisioning. It also supports the principle of continuous improvement by establishing a baseline for performance and identifying areas for ongoing refinement. Incorrect approach is analysis. One incorrect approach is to solely focus on increasing hardware capacity without a thorough analysis of current resource utilization. This can lead to significant capital expenditure on hardware that may not be fully utilized, resulting in wasted resources and increased operational costs. It fails to address potential inefficiencies in resource allocation or workload scheduling within the existing infrastructure. Another incorrect approach is to implement performance tuning changes based on anecdotal evidence or isolated incidents without comprehensive data analysis. This can lead to unintended consequences, such as performance degradation in other virtual machines or system instability. It bypasses the systematic, data-driven methodology required for effective process optimization and risks introducing new problems while attempting to solve existing ones. A third incorrect approach is to prioritize cost reduction by aggressively overcommitting resources or reducing essential monitoring and management tools. While cost savings are important, such actions can severely impact performance, reliability, and the ability to detect and respond to issues, potentially leading to costly downtime and non-compliance with service-level agreements. This approach neglects the fundamental requirement of maintaining a stable and performant virtualized environment. Professional reasoning. Professionals should adopt a data-driven, iterative approach to process optimization. This involves establishing clear performance baselines, continuously monitoring key metrics, and using this data to inform decisions about resource allocation, configuration changes, and infrastructure scaling. Regular reviews and adjustments, guided by performance analysis and business requirements, are crucial. When considering any optimization, a thorough impact assessment should be conducted, and changes should be implemented in a controlled manner, ideally in a test environment or during scheduled maintenance windows, with rollback plans in place. This systematic approach ensures that optimization efforts are effective, sustainable, and do not compromise the integrity or performance of the virtualized data center. Question 8. When evaluating the efficiency of resource allocation within a VMware vSphere environment to optimize operational processes, which of the following strategies best embodies a proactive and data-driven approach to continuous improvement? Option A. Relying on vendor recommendations for resource sizing without independent verification or ongoing monitoring of actual workload performance. Option B. Reactively increasing virtual machine resources only when end users report performance degradation and decreasing them when complaints subside. Option C. Periodically reviewing and reducing the allocated resources for virtual machines that have not recently experienced high utilization without correlating this to application performance needs. Option D. Implementing automated resource adjustments based on predefined thresholds for CPU and memory utilization, coupled with regular performance metric analysis to identify trends and potential bottlenecks. Correct answer is D. Implementing automated resource adjustments based on predefined thresholds for CPU and memory utilization, coupled with regular performance metric analysis to identify trends and potential bottlenecks. Explanation. This scenario presents a common challenge in data center virtualization, optimizing resource allocation to meet evolving business demands without compromising performance or incurring unnecessary costs. The professional challenge lies in balancing the dynamic nature of virtualized environments with the need for predictable and efficient operations, all while adhering to the principles of process optimization. Careful judgment is required to select a strategy that is both technically sound and aligns with the overarching goals of the organization. The correct approach represents best professional practice because it directly addresses the core tenets of process optimization by focusing on continuous improvement and data-driven decision-making. By establishing baseline metrics and regularly analyzing performance data, it allows for proactive identification of bottlenecks and inefficiencies. This systematic approach ensures that resource allocation is not only adequate but also optimized for cost-effectiveness and performance, aligning with the principles of efficient IT service delivery. An incorrect approach that relies solely on reactive adjustments fails to establish a baseline or a structured method for improvement. This can lead to a cycle of constant firefighting, where resources are added or removed without a clear understanding of the impact, potentially causing performance degradation or overspending. This lack of a systematic process is a failure in professional diligence and can lead to suboptimal resource utilization, which indirectly impacts the organization's ability to meet service-level agreements and business objectives. Another incorrect approach that focuses only on cost reduction without considering performance implications is also professionally unsound. While cost efficiency is important, it should not come at the expense of service quality. Arbitrarily reducing resources without a thorough analysis of their impact on critical applications can lead to performance issues, user dissatisfaction, and ultimately, a negative impact on business operations. This demonstrates a failure to understand the interconnectedness of resources, performance, and business outcomes. The professional reasoning process for similar situations should involve a structured approach to process optimization. This includes defining clear objectives for optimization, establishing measurable baseline metrics, implementing a continuous monitoring and analysis framework, identifying areas for improvement through data analysis, piloting changes, and then implementing and monitoring the optimized processes. This iterative and data-driven methodology ensures that decisions are informed and that the resulting optimizations are sustainable and beneficial to the organization. Question 9. The performance metrics show a consistent increase in VM ready time across several critical applications, yet end users are reporting intermittent application slowdowns that are not always reproducible. The virtualization administrator suspects a configuration issue, but is unsure of the most effective next step to diagnose and resolve the problem without impacting other services. Option A. Advise stakeholders that the performance metrics are likely inaccurate and recommend a complete migration to a new virtualization platform. Option B. Rely solely on user feedback to troubleshoot the slowdowns, disregarding the detailed performance metrics as potentially misleading. Option C. Immediately increase CPU and RAM reservations for all VMs experiencing reported slowdowns to ensure they have guaranteed resources. Option D. Review the VMware vSphere configuration for resource allocation, scheduling, and storage I/O control settings, correlating findings with the performance metrics to identify specific bottlenecks. The correct answer is D. Review the VMware vSphere configuration for resource allocation, scheduling, and storage I/O control settings, correlating findings with the performance metrics to identify specific bottlenecks. Explanation. Scenario analysis. The scenario presents a common challenge in data center virtualization, a discrepancy between perceived performance and actual measured metrics. This creates a conflict between stakeholder expectations, likely driven by user experience or business needs, and the technical reality. The challenge lies in bridging this gap, ensuring that decisions are data-driven, compliant with operational best practices, and effectively communicated to stakeholders. The need to balance performance, cost, and resource utilization, while adhering to VMware's recommended configurations and potential licensing implications. Though not explicitly a regulatory concern in this context, it's a practical constraint, makes this a complex decision point. Correct approach analysis. The correct approach involves a systematic investigation rooted in the provided performance metrics. This means correlating the observed performance issues with specific resource bottlenecks identified by the metrics, e.g., CPU ready time, memory ballooning, storage latency. The subsequent action of reviewing the VMware vSphere configuration, specifically focusing on resource allocation, scheduling, and storage I/O control settings, directly addresses the potential root causes indicated by the data. This aligns with best practices for performance tuning in VMware environments, emphasizing a data-driven, methodical troubleshooting process. It ensures that any proposed changes are justified by evidence and are likely to yield tangible improvements without introducing new problems. This approach prioritizes operational stability and efficiency, which are implicit goals in maintaining a robust data center infrastructure. Incorrect approach is analysis. One incorrect approach would be to immediately implement aggressive resource over-provisioning, e.g., increasing CPU and RAM reservations for all VMs, without a clear understanding of the root cause. This is professionally unsound because it ignores the performance metrics and risks significant cost increases due to unnecessary licensing or hardware upgrades. Ethically, it represents a failure to act responsibly with organizational resources and could lead to performance degradation in other areas due to resource contention. It also bypasses the due diligence required to identify the actual problem. Another incorrect approach would be to dismiss the performance metrics as inaccurate and rely solely on anecdotal user feedback. This is a failure of professional judgment and a disregard for objective data. It can lead to misdiagnosis of issues, wasted troubleshooting efforts, and ultimately, a failure to resolve the underlying performance problems. From a best practice standpoint, It undermines the value of monitoring tools and data analysis, which are critical for effective data center management. A third incorrect approach would be to propose a complete infrastructure overhaul or migration to a different platform based on the initial perception of poor performance, without thoroughly investigating the current environment. This is premature and potentially wasteful. It fails to leverage the existing investment and ignores the possibility that the issues are configuration-related or solvable within the current framework. This approach demonstrates a lack of methodical problem-solving and a tendency towards drastic, unverified solutions. Professional reasoning. Professionals should approach such situations by first prioritizing data collection and analysis. Performance metrics are the primary source of truth. The decision-making process should involve 1. Understanding the reported issue and its business impact. 2. Correlating the issue with the available performance data to identify potential bottlenecks. 3. Formulating hypotheses based on the data. 4. Developing a targeted investigation plan focusing on the most likely causes within the VMware configuration. 5. Implementing changes incrementally and monitoring their impact. 6. Communicating findings and proposed solutions transparently to stakeholders, backed by data. This systematic, data-driven approach ensures that solutions are effective, efficient, and justifiable. Question 10. System analysis indicates a stakeholder has requested the immediate allocation of additional compute resources to a production virtual environment. The current VMware vSphere environment is licensed under a specific edition, and the proposed resource expansion may exceed the limits or terms of the existing license agreement. What is the most professionally responsible course of action to ensure compliance and mitigate risk? Option A. Halt the resource allocation until a thorough review of the current VMware licensing agreements is conducted to confirm that the expansion is compliant with all terms and conditions. Option B. Consult with the VMware sales representative to confirm if the existing licenses can accommodate the requested resource expansion before proceeding. Option C. Immediately allocate the requested resources, assuming that the existing licenses will cover the expansion, and address any potential discrepancies later if they arise. Option D. Proceed with the resource allocation and initiate a review of licensing compliance after the expansion is complete. The correct answer is D. Proceed with the resource allocation and initiate a review of licensing compliance after the expansion is complete. Explanation. Scenario analysis. This scenario presents a common challenge in data center virtualization, balancing the immediate need for resource allocation with the long-term implications of licensing compliance. The challenge lies in the potential for misinterpretation of licensing terms, which can lead to significant financial penalties and operational disruptions. The stakeholder's request, while seemingly straightforward, carries inherent risks if not handled with a thorough understanding of the VMware licensing model and its implications for the specific virtual environment. The pressure to deliver quickly can tempt a shortcut, but this would be professionally irresponsible. Correct approach analysis. The correct approach involves a meticulous review of the existing VMware licensing agreements and a clear understanding of how the requested resource allocation impacts those licenses. This aligns with the professional responsibility to ensure compliance with all contractual obligations and regulatory frameworks governing software usage. For VMware, this means understanding the nuances of per-processor or per-core licensing, vSphere editions, and any associated support and subscription terms. Proactively verifying that the proposed deployment adheres to these terms before implementation is the cornerstone of responsible IT management and avoids potential legal and financial repercussions. This approach demonstrates due diligence and a commitment to maintaining a compliant and secure operational environment. Incorrect approach is analysis. Implementing the resource allocation without verifying licensing compliance is a direct violation of contractual agreements with VMware. This failure to adhere to licensing terms can result in audits, substantial fines, and the requirement to purchase additional licenses retroactively, which is a significant financial burden. Ethically, it represents a breach of trust with the organization, as it exposes them to unnecessary risk. Assuming that existing licenses will cover the new resources without explicit verification is a form of negligence. It relies on assumptions rather than facts, which is professionally unsound. This can lead to accidental noncompliance, which carries the same penalties as intentional noncompliance. The ethical failure here is the lack of diligence and the potential to mislead stakeholders about the true compliance status. Consulting only with the vendor representative without independently verifying the licensing terms is also problematic. While vendor representatives can be helpful, their primary role is to sell products and services. Their interpretation of licensing may not always be the most conservative or legally robust from the customer's perspective. Relying solely on their word without cross-referencing with the official licensing documentation or seeking independent legal counsel, if the situation warrants, is a failure of due diligence and can lead to misinterpretations that result in noncompliance. The ethical concern is the potential for a conflict of interest and the failure to act solely in the best interest of the organization. Professional reasoning. Professionals in data center virtualization must adopt a proactive and compliance-centric approach. When faced with requests that could impact licensing, the decision-making process should involve 1. Understanding the request. Clearly define the scope and impact of the proposed change. 2. Reviewing documentation. Thoroughly examine all relevant licensing agreements, terms of service, and product documentation. 3. Seeking clarification. If any aspect of the licensing is unclear, engage with the vendor's licensing specialists or legal department for definitive interpretation. 4. Internal consultation. Discuss the implications with internal legal and procurement teams. 5. Risk assessment. Evaluate the potential financial and operational risks associated with different courses of action. 6. Informed decision. Make a decision based on verified information and a clear understanding of compliance requirements, prioritizing long-term stability and legal adherence over short-term expediency. Question 11. The audit findings indicate a potential misconfiguration in the vSphere environment related to storage I/O control settings that may be impacting the performance of critical virtual machines. What is the most appropriate course of action for the virtualization administrator? Option A. Immediately disable storage I/O control on the affected data stores to revert to default behavior and monitor performance. Option B. Apply a configuration change recommended by an online forum post that claims to resolve similar performance issues without further investigation or testing. Option C. Ignore the audit finding as the performance impact is not currently causing critical business disruptions and focus on other immediate operational tasks. Option D. Thoroughly document the current storage I/O control configuration. Identify the specific audit finding. Research potential causes and solutions. Develop a detailed remediation plan including testing in a lab environment and a rollback strategy, and then schedule the change during a planned maintenance window after stakeholder notification. The correct answer is A. Immediately disable storage I/O control on the affected data stores to revert to default behavior and monitor performance. Explanation. The audit findings indicate a potential misconfiguration in the vSphere environment that could impact the availability and integrity of critical data. This scenario is professionally challenging because it requires the virtualization administrator to balance the immediate need for remediation with the potential for unintended consequences, such as service disruption or data loss, if changes are not carefully planned and executed. The administrator must also consider the impact on various stakeholders, including business units relying on the affected services and IT management responsible for operational stability. Correct approach, which involves thoroughly documenting the existing configuration, identifying the root cause of the audit finding, developing a detailed remediation plan with rollback procedures, testing the proposed changes in a non-production environment, and then scheduling and executing the changes during a maintenance window with stakeholder notification, represents best professional practice. This approach aligns with the principles of IT service management, risk management, and change control, which are implicitly expected in a professional VMware environment. It ensures that changes are controlled, predictable, and minimize disruption, thereby upholding the integrity and availability of the virtualized infrastructure. An incorrect approach, such as immediately reverting the configuration without understanding the impact or the reason for the current setting, fails to address the root cause and could lead to further instability or data corruption. This demonstrates a lack of due diligence and a failure to adhere to proper change management protocols, potentially violating internal IT policies and best practices for system administration. Another incorrect approach, like applying a fix based on anecdotal evidence from online forums without validation or testing, is highly risky. This bypasses established testing and validation procedures, increasing the likelihood of introducing new issues or exacerbating the existing problem. It disregards the principle of evidence-based decision-making and could lead to significant operational failures, impacting business continuity and potentially violating service-level agreements. A third incorrect approach, such as ignoring the audit finding due to perceived low risk or resource constraints, is a direct abdication of professional responsibility. This failure to address identified risks can lead to security vulnerabilities, performance degradation, or compliance issues, all of which can have severe business consequences. It demonstrates a disregard for proactive system management and risk mitigation, which are fundamental to maintaining a stable and secure IT environment. The professional reasoning process for similar situations should involve a structured approach. First, understand the problem and its potential impact. Second, gather all relevant information and assess the risks. Third, develop and evaluate potential solutions, prioritizing those that are tested, documented, and controlled. Fourth, communicate the plan and its implications to stakeholders. And finally, execute the chosen solution with a clear rollback strategy in place. Question 12. Process analysis reveals that a critical business application hosted on a VMware vSphere virtual machine is experiencing intermittent performance degradation, impacting user productivity. The virtual machine is part of a larger cluster with multiple other virtual machines running various workloads. The virtual machine's host is not reporting any overall host-level resource exhaustion, but the application's performance metrics within the guest OS indicate high CPU and disk latency during these periods. The IT operations team is under pressure to resolve this issue quickly to restore full application functionality and meet service-level agreements. What is the most appropriate course of action to address this performance degradation? Option A. Disable all resource management features, shares, limits, reservations for the affected virtual machine to allow it unrestricted access to host resources. Option B. Analyze the performance metrics of the affected virtual machine and its host using vSphere performance monitoring tools to identify specific resource bottlenecks, CPU, memory, disk I/O network, and then implement targeted resource management adjustments, e.g., shares, limits, reservations, or investigate potential guest OS or application-level issues. Option C. Migrate the affected virtual machine to a different host within the cluster that appears to have lower overall utilization, without further investigation into the cause of the performance issue. Option D. Immediately increase the CPU and memory reservations for the affected virtual machine to their maximum allowable values to ensure it always has dedicated resources. The correct answer is D. Immediately increase the CPU and memory reservations for the affected virtual machine to their maximum allowable values to ensure it always has dedicated resources. Explanation. Scenario analysis. The scenario presents a common challenge in data center virtualization, managing resource contention and ensuring application performance under fluctuating demand. The professional is tasked with optimizing resource allocation for a critical application without negatively impacting other services. This requires a nuanced understanding of VMware vSphere resource management features and their implications for application stability and service-level agreements, SLAs. The challenge lies in balancing the immediate need for performance with the long-term stability and resource availability for the entire virtualized environment. A hasty or poorly informed decision can lead to cascading performance issues, service disruptions, and potential breaches of SLAs, all of which carry significant professional and organizational risk. Correct approach analysis. The correct approach involves a systematic, data-driven method to identify the root cause of the performance degradation and implement targeted adjustments. This aligns with best practices in IT service management and VMware's recommended operational procedures, specifically utilizing vSphere's performance monitoring tools, e.g., vCenter Performance Charts (SCTOP), to analyze CPU, memory, disk, and network utilization for the affected virtual machine and its host is crucial. This data-driven approach allows for precise identification of bottlenecks. Based on this analysis, applying resource pools with appropriate shares, reservations, and limits, or adjusting affinity rules, can be done with a high degree of confidence. This method minimizes the risk of unintended consequences by ensuring that changes are based on observed behavior and directly address the identified issues, thereby upholding service quality and meeting SLA commitments. Incorrect approach is analysis. Implementing a blanket increase in resource allocation for all virtual machines on the host without prior analysis is a regulatory and ethical failure. This approach disregards the principle of least privilege and efficient resource utilization, potentially starving other critical applications and violating resource governance policies. It also fails to address the specific root cause, leading to wasted resources and potential performance degradation elsewhere. Disabling resource management features like shares or limits entirely for the affected virtual machine is also professionally unacceptable. This action removes critical safeguards designed to prevent resource starvation and ensure fair resource distribution across the environment. It can lead to uncontrolled resource consumption by a single VM, impacting the performance and availability of other services and potentially violating SLAs. This demonstrates a lack of understanding of the fundamental principles of resource management in a virtualized environment. Manually migrating the virtual machine to a different host without understanding the underlying resource contention is a reactive and potentially disruptive approach. While it might temporarily alleviate the issue on the original host, it does not resolve the root cause and could simply shift the problem or create new ones on the destination host. This approach lacks a systematic problem-solving methodology and can lead to inefficient resource utilization and increased operational overhead. Professional reasoning. Professionals should employ a structured decision-making framework that prioritizes data analysis and impact assessment. This framework typically involves 1. Problem identification. Clearly define the observed issue and its impact. 2. Data gathering. Collect relevant performance metrics and configuration data. 3. Root cause analysis. Analyze the gathered data to pinpoint the underlying cause. 4. Solution design. Develop targeted solutions based on the root cause. 5. Impact assessment. Evaluate the potential consequences of proposed solutions on the entire environment. 6. Implementation and monitoring. Deploy the solution and continuously monitor its effectiveness. 7. Documentation. Record all actions and outcomes for future reference and auditing. This systematic approach ensures that decisions are informed, justifiable, and aligned with organizational objectives and best practices. Question 13. The assessment process reveals that a critical application hosted on a VMware vSphere cluster is experiencing intermittent performance degradation following a recent firmware update to the storage array. The issue is impacting end users, and the pressure to restore full performance is high. The virtualization administrator has identified a potential workaround involving a specific vSphere advanced setting that is rumored to alleviate similar issues. But this setting has not been formally tested or approved for production use. What is the most professionally responsible course of action to address this performance degradation? Option A. Initiate a formal incident response process. Conduct a thorough root cause analysis of the storage firmware updates interaction with vSphere, and then propose and test a validated solution, potentially including a rollback of the firmware or a carefully planned vSphere configuration change. Option B. Advise the application owners to temporarily reduce the application's workload to mitigate the performance impact while a solution is sought. Option C. Immediately implement the rumored vSphere advanced setting workaround to restore application performance, as the business impact is significant and time is of the essence. Option D. Revert the storage array firmware to its previous version without further investigation, assuming the firmware update is the sole cause of the problem. The correct answer is C. Immediately implement the rumored vSphere advanced setting workaround to restore application performance, as the business impact is significant and time is of the essence. Explanation. Scenario analysis. This scenario presents a common challenge in data center virtualization, where a critical performance issue arises during a planned maintenance window. The challenge lies in balancing the urgency of resolving the issue with the need to adhere to established change management and incident response procedures. The pressure to restore service quickly can lead to bypassing necessary steps, potentially exacerbating the problem or introducing new risks. The professional must make a rapid, informed decision under duress, considering the impact on business operations and the integrity of the virtualized environment. Correct approach analysis. The correct approach prioritizes a structured incident response and problem-solving methodology. This involves accurately identifying the root cause through systematic investigation, validating potential solutions in a controlled manner, e.g., a test environment or during a low-impact period if feasible, and then implementing the fix following the established change control process. This ensures that the resolution is effective, minimizes further disruption, and maintains auditability. Adherence to documented procedures, even under pressure, is a cornerstone of professional IT operations and aligns with best practices for maintaining a stable and secure data center environment. Incorrect approaches analysis. One incorrect approach involves immediately reverting to a previous stable state without a thorough root cause analysis. While seemingly a quick fix, this bypasses understanding why the issue occurred, leaving the underlying vulnerability unaddressed and increasing the likelihood of recurrence. This can be seen as a failure in due diligence and proactive problem management. Another incorrect approach is to implement a solution based on anecdotal evidence or assumptions without proper validation. This risks introducing further instability or unintended consequences, as the proposed fix may not address the actual root cause or may have adverse effects on other components of the virtual infrastructure. This demonstrates a lack of rigor and potentially violates principles of responsible system administration. A third incorrect approach is to bypass the change control process entirely to expedite the fix. While the intention might be to restore service quickly, this action undermines the established governance and risk management framework. It can lead to a lack of documentation, incomplete testing, and an inability to track changes effectively, which are critical for compliance and future troubleshooting. Professional reasoning. Professionals should employ a decision-making framework that emphasizes systematic problem-solving, risk assessment, and adherence to established procedures. This framework involves 1. Incident identification and prioritization. Clearly define the issue and its impact. 2. Diagnosis and root cause analysis. Employ methodical troubleshooting techniques. 3. Solution development and validation. Propose and test potential fixes. 4. Implementation and change control. Execute the solution following approved processes. 5. Verification and closure. Confirm resolution and document lessons learned. This structured approach ensures that decisions are data-driven, risks are managed, and operational integrity is maintained. Question 14. Risk assessment procedures indicate that a critical business application requires immediate deployment on a new vSphere cluster. The infrastructure team has identified that the existing vSphere licenses are CPU-based, and the new cluster will utilize servers with CPUs that have a higher core count than previously deployed hardware. The team needs to determine the most appropriate licensing strategy to ensure compliance without delaying the critical deployment. Option A. Immediately halt the deployment and engage in a comprehensive review of the current VMware vSphere licensing documentation, including specific terms for the vSphere edition and the licensing metrics for multi-core CPUs, and consult with VMware's licensing specialists to confirm the exact licensing requirements before proceeding. Option B. Rely on the understanding that vSphere licensing is generally flexible and that the sales representative indicated that most deployments of this nature are covered by existing licenses, proceeding with the deployment based on this informal assurance. Option C. Proceed with the deployment using the existing license keys, assuming that the per-CPU licensing model will accommodate the increased core count on the new CPUs, and address any potential discrepancies post-deployment if an audit occurs. Option D. Deploy the new cluster using the existing licenses and request a trial extension from VMware for the new hardware, with the intention of purchasing additional licenses only if the trial is not approved or if an audit is initiated. The correct answer is C. Proceed with the deployment using the existing license keys, assuming that the per-CPU licensing model will accommodate the increased core count on the new CPUs, and address any potential discrepancies post-deployment if an audit occurs. Explanation. Scenario analysis. This scenario presents a common challenge in data center virtualization, balancing the immediate need for resource allocation with the long-term implications of licensing compliance. The challenge lies in the potential for misinterpretation of licensing terms, which can lead to significant financial penalties and operational disruptions if not managed proactively. The pressure to deploy resources quickly for a critical business function can create a temptation to bypass thorough due diligence, making a structured decision-making process essential. Correct approach analysis. The correct approach involves a meticulous review of the VMware vSphere licensing documentation, specifically focusing on the terms and conditions related to CPU-based licensing and any applicable subscription or support agreements. This aligns with the principle of due diligence and adherence to contractual obligations, which are fundamental to maintaining a compliant and legally sound IT infrastructure. By consulting the official licensing guides and potentially engaging with VMware's licensing specialists, the organization ensures that its deployment strategy is fully compliant with the vendor's terms, thereby mitigating the risk of audit failures, unexpected costs, and potential legal disputes. This proactive stance is a hallmark of professional IT management, prioritizing long-term stability and risk avoidance over short-term expediency. Incorrect approach is analysis. One incorrect approach is to proceed with the deployment based on a general understanding of previous licensing models without verifying current terms. This fails to acknowledge that licensing agreements can change and that specific product versions or editions may have unique stipulations. This oversight constitutes a regulatory failure, as it disregards the explicit terms of the contract with VMware, potentially leading to non-compliance. Ethically, it represents a lack of diligence and a failure to act in the best interest of the organization by exposing it to unnecessary risk. Another incorrect approach is to rely solely on the recommendations of the sales team without independent verification. While sales teams aim to facilitate business, their primary focus is not on providing definitive legal interpretations of licensing agreements. This approach risks misinterpreting the scope of licenses or overlooking critical clauses. The regulatory failure here is the abdication of responsibility for ensuring compliance, placing undue trust in a party whose incentives may not align perfectly with the organization's legal obligations. Ethically, it demonstrates a lack of independent judgment and a failure to perform thorough due diligence. A third incorrect approach is to assume that a per CPU license automatically covers all physical cores on a CPU, regardless of the vSphere edition or specific licensing metrics. This is a common misconception that can lead to significant underlicensing. The regulatory failure is the direct violation of the licensing agreement by deploying resources in a manner not permitted by the purchased licenses. Ethically, it is a breach of trust with the vendor and a failure to uphold professional standards of integrity and compliance. Professional reasoning. Professionals should employ a decision-making framework that prioritizes verification and compliance. This involves 1. Identifying the specific VMware product and version being deployed. 2. Locating and thoroughly reviewing the official licensing documentation for that product and version. 3. Consulting with internal legal counsel or a specialized licensing consultant if any ambiguities exist. 4. Documenting the interpretation and the basis for the deployment decision. This systematic approach ensures that all decisions are informed, defensible, and aligned with both contractual obligations and best professional practices. Question 15. The risk matrix shows a moderate likelihood of a critical system failure impacting customer transaction processing, with a high potential impact on revenue and regulatory compliance. A recent, unconfirmed report suggests a potential data corruption issue within this system. Which of the following actions best aligns with a proactive and compliant approach to managing this situation? Option A. Temporarily disable the affected system and await further instructions from senior management to avoid any potential missteps. Option B. Proceed with a partial system rollback to a known stable state, assuming the corruption is isolated to recent changes. Option C. Immediately initiate a full system restore from the most recent available backup to minimize downtime and revenue loss. Option D. Conduct a rapid impact assessment to determine the scope of potential data corruption. Identify affected data sets, and evaluate the implications for transaction integrity and regulatory reporting before proceeding with any recovery actions. The correct answer is C. Immediately initiate a full system restore from the most recent available backup to minimize downtime and revenue loss. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for system availability with the long-term implications of potential data loss or corruption. The pressure to restore services quickly can lead to shortcuts that bypass essential impact assessment steps, potentially causing more significant disruption and regulatory noncompliance down the line. Careful judgment is required to ensure that the chosen recovery strategy is not only fast but also robust and compliant. The correct approach represents best professional practice because it prioritizes a thorough impact assessment before implementing any recovery actions. This aligns with the principles of responsible IT governance and risk management, which are often implicitly or explicitly mandated by regulatory frameworks governing data protection and business continuity. By understanding the potential impact on critical business functions, data integrity, and regulatory obligations, IT professionals can make informed decisions that minimize overall risk. This proactive approach ensures that recovery efforts are targeted, effective, and do not inadvertently violate data retention policies or introduce new vulnerabilities. An incorrect approach that focuses solely on rapid restoration without considering the scope of the incident or its potential downstream effects represents a significant regulatory and ethical failure. For instance, restoring from an outdated backup without verifying data integrity could lead to the reintroduction of malware or the loss of critical transactions, violating data accuracy and integrity requirements. Similarly, bypassing security protocols during recovery to speed up the process could expose sensitive data, leading to breaches of confidentiality and privacy regulations. Failing to document the impact assessment and recovery steps also undermines auditability and accountability, which are fundamental to regulatory compliance. Professionals should employ a decision-making framework that begins with incident identification and containment, followed by a rapid but comprehensive impact assessment. This assessment should consider the criticality of affected systems, the sensitivity of data involved, potential legal and regulatory implications, and the business impact of downtime. Based on this assessment, a recovery strategy can be formulated, prioritizing data integrity and security alongside speed. Continuous monitoring and validation throughout the recovery process are crucial to ensure that the chosen approach is effective and compliant. Question 16. System analysis indicates a proposed upgrade to the storage array firmware is expected to enhance read/write performance for critical virtual machines. However, the current virtual infrastructure is complex, with numerous interconnected virtual machines running diverse applications and relying on shared storage resources. The vendor has provided documentation suggesting the upgrade is seamless and will not impact existing configurations. What is the most professional and responsible course of action to ensure the integrity and stability of the data center virtualization environment? Option A. Proceed with the firmware upgrade in the production environment immediately, as the vendor's documentation guarantees a seamless process and the performance benefits are significant. Option B. Rely solely on the vendor's assurances and documentation and schedule the firmware upgrade during a low-usage period without further internal testing or analysis. Option C. Implement the firmware upgrade on a single, non-critical virtual machine first to observe its behavior, and if no immediate issues arise, then proceed with the production upgrade. Option D. Conduct a comprehensive impact assessment that includes testing in a non-production environment, analyzing potential effects on all virtual machines, applications, and shared storage, and developing a detailed rollback plan before proceeding with the production upgrade. The correct answer is D. Conduct a comprehensive impact assessment that includes testing in a non-production environment, analyzing potential effects on all virtual machines, applications, and shared storage, and developing a detailed rollback plan before proceeding with the production upgrade. Explanation. Scenario analysis. This scenario presents a common challenge in data center virtualization where a proposed change, while seemingly beneficial for performance, carries inherent risks. The professional's responsibility is to balance the potential gains against the potential disruptions and ensure that any impact is understood and mitigated before implementation. The challenge lies in the interconnectedness of virtualized environments. A change in one area can have unforeseen consequences elsewhere. This requires a thorough understanding of the existing infrastructure, the proposed change, and the potential ripple effects. Correct approach analysis. A comprehensive impact assessment is the cornerstone of responsible IT change management. This process involves identifying all potential consequences of a proposed change on the existing infrastructure, applications, and business operations. It requires detailed documentation of the current state, a clear understanding of the proposed change's technical specifications, and a systematic evaluation of risks and benefits. By performing a thorough impact assessment, the professional ensures that all stakeholders are informed, potential issues are identified proactively, and mitigation strategies can be developed. This aligns with best practices in IT service management and risk management, ensuring business continuity and minimizing service disruption. Incorrect approaches analysis. Failing to conduct any assessment or relying solely on anecdotal evidence from a single vendor is a significant professional failure. This approach ignores the unique configuration and interdependencies of the specific data center environment. It bypasses established change management protocols designed to prevent unintended consequences and service outages. This is ethically unsound as it prioritizes expediency over due diligence, potentially jeopardizing business operations and data integrity. Implementing the change based on the vendor's assurance without independent verification demonstrates a lack of critical evaluation and an over-reliance on external parties. While vendor input is valuable, it should not replace an internal assessment that considers the specific context of the deployed environment. This approach risks overlooking compatibility issues or performance bottlenecks that might not be apparent to the vendor. It also fails to meet the professional obligation to ensure the stability and reliability of the IT infrastructure, focusing only on the immediate performance metrics of the proposed change, without considering its broader impact on other systems, applications, or security protocols, is a narrow and incomplete approach. This overlooks potential negative side effects such as increased resource contention, security vulnerabilities, or compatibility issues with existing software. A responsible professional must consider the holistic impact on the entire data center ecosystem. Professional reasoning. Professionals should adopt a structured approach to change management, beginning with a formal request for change. This request should trigger a mandatory impact assessment process. The assessment should involve a multidisciplinary team, including system administrators, network engineers, application owners, and security personnel. The process should include documenting the current state, detailing the proposed change, identifying all affected components and services, evaluating potential risks, technical, operational, security, estimating the benefits, and developing a rollback plan. This systematic process ensures that decisions are data-driven, risks are managed, and the overall stability and performance of the data center are maintained. Question 17. Quality control measures reveal a significant and unexpected degradation in virtual machine performance across multiple hosts following a planned upgrade of the vSphere distributed switch configuration. The operations team is under pressure to restore full performance immediately. Which of the following actions represents the most professional and effective initial response? Option A. Begin systematically rebooting individual virtual machines and hosts in an attempt to identify a pattern of recovery. Option B. Focus exclusively on performing hardware diagnostics on the affected hosts to rule out physical infrastructure failures. Option C. Conduct a detailed impact assessment by analyzing performance metrics, reviewing vSphere logs, and correlating the degradation with the timing of the distributed switch configuration change. Option D. Immediately initiate a rollback of the vSphere distributed switch configuration to its previous state without further investigation. Correct answer is D. Immediately initiate a rollback of the vSphere distributed switch configuration to its previous state without further investigation. Explanation. Scenario analysis. The scenario presents a common challenge in data center virtualization: unexpected performance degradation following a planned infrastructure change. The professional's task is to identify the root cause and implement a solution while minimizing further disruption. The challenge lies in the potential for cascading failures, data integrity risks, and the need to balance immediate remediation with long-term stability, all within the context of maintaining service-level agreements, SLAs, and adhering to operational best practices. Correct approach analysis. The correct approach involves a systematic, data-driven investigation. This begins with a thorough impact assessment, meticulously documenting the observed symptoms and correlating them with the recent change. It prioritizes isolating the affected components, analyzing performance metrics before and after the change, and consulting relevant logs and monitoring tools. This methodical process ensures that the root cause is accurately identified, preventing the application of incorrect fixes that could exacerbate the problem. This aligns with best practices for incident management and change control, emphasizing a structured response to minimize risk and restore service efficiently. Incorrect approaches analysis. One incorrect approach involves immediately reverting the change without a proper impact assessment. This is professionally unsound because it bypasses the opportunity to understand the underlying issue. Reverting without analysis might mask a deeper problem or fail to address the true cause, leading to recurrence. It also violates change management principles by not documenting the failure and its resolution, hindering future troubleshooting and knowledge sharing. Another incorrect approach is to focus solely on hardware diagnostics without considering the software or configuration changes. While hardware can fail, the timing of the degradation immediately after a planned change strongly suggests a correlation. Ignoring the recent change as a potential factor is a failure of logical deduction and a deviation from a comprehensive troubleshooting methodology. This can lead to wasted resources on unnecessary hardware replacements and prolonged downtime. A third incorrect approach is to implement a series of random configuration adjustments across various components in an attempt to fix the issue. This is highly risky and unprofessional. It introduces further instability, makes it impossible to determine which adjustment, if any, resolve the problem, and can easily lead to more severe system failures or data corruption. This approach lacks any semblance of a structured troubleshooting methodology and is a direct contravention of responsible system administration. Professional reasoning. Professionals should approach such situations by first acknowledging the incident and initiating an incident response process. This involves clear communication with stakeholders, followed by a structured impact assessment. The assessment should leverage available data, logs, and monitoring tools to form hypotheses about the root cause. Troubleshooting should then proceed in a controlled manner, prioritizing changes that are least likely to cause further disruption. Documentation at every step is crucial for learning and future reference. Question 18. The control framework reveals that a recent VMware vSphere upgrade, intended to enhance security patching capabilities, has caused a critical financial application to become unresponsive. The application team reports that the application is completely inaccessible, impacting all financial transactions. The virtualization team has confirmed the upgrade was completed successfully from a vSphere perspective, but the application's failure is directly correlated with the upgrade's deployment. What is the most appropriate immediate course of action to mitigate the business impact? Option A. Attempt a partial rollback of specific vSphere components that might be related to the application. Option B. Document the incident and continue monitoring the application's status. Option C. Immediately begin troubleshooting the financial application's code and configuration. Option D. Initiate a rollback of the vSphere upgrade to the previous stable version. The correct answer is D. Initiate a rollback of the vSphere upgrade to the previous stable version. Explanation. Scenario analysis. This scenario presents a common challenge in data center virtualization, where a planned infrastructure upgrade, intended to improve performance and security, has an unforeseen and significant impact on a critical business application. The challenge lies in balancing the benefits of the upgrade with the potential disruption to business operations. The professional must quickly assess the situation, understand the root cause of the application's failure, and determine the most appropriate course of action to restore service while adhering to established IT governance and operational procedures. The pressure to resolve the issue rapidly, coupled with the need to maintain data integrity and compliance, makes this a high-stakes situation. Correct approach analysis. The correct approach involves a systematic rollback of the virtualization upgrade to the last known stable state. This is the best professional practice because it prioritizes the immediate restoration of critical business functionality. In the context of data center virtualization, especially within a regulated environment, even if not explicitly stated, professional practice implies adherence to internal policies and potentially industry standards. Ensuring application availability is paramount. A rollback minimizes downtime and data loss, directly addressing the immediate business impact. This action aligns with the principle of least disruption when faced with an unexpected and severe operational failure. It allows for subsequent, more controlled investigation and reimplementation of the upgrade. Correct approaches analysis. Attempting to immediately fix the application without reverting the underlying infrastructure change is a significant regulatory and ethical failure. It ignores the most probable cause of the failure and risks further destabilizing the environment. This approach could lead to prolonged downtime, data corruption, and potential breaches of service-level agreements, SLAs, which often have regulatory implications regarding business continuity. Focusing solely on documenting the failure without taking immediate corrective action is also professionally unacceptable. While documentation is crucial, it does not address the immediate business impact. This inaction could be seen as a failure to uphold professional responsibilities for operational stability and could violate internal policies or external regulations requiring timely resolution of critical incidents. Implementing a partial rollback or attempting to selectively revert parts of the upgrade is highly risky. This can lead to an inconsistent and unstable environment, potentially causing more complex issues than the original problem. It demonstrates a lack of thorough understanding of the upgrade's interdependencies and a failure to follow established disaster recovery or rollback procedures, which are often mandated by compliance frameworks. Professional reasoning. Professionals facing such a scenario should first activate their incident response plan. This plan should outline steps for immediate containment, diagnosis, and resolution. The primary goal is always to restore critical services as quickly as possible. This involves a rapid assessment of the impact, identification of the likely cause, and the selection of the most effective remediation strategy. In cases of infrastructure changes causing application failure, a rollback to a known good state is often the safest and fastest way to restore service. Following the rollback, a thorough root cause analysis, RCA, should be conducted in a controlled environment to understand the failure and plan for a successful reimplementation of the upgrade, ensuring all stakeholders are informed throughout the process. Question 19. The audit findings indicate that the vSphere environment's network configuration for vMotion and storage vMotion traffic is utilizing a single, non-redundant physical network path, creating a potential single point of failure that could disrupt critical data center operations and impact data availability during a network outage. Option A. Disable vMotion and storage vMotion functionality until the network infrastructure can be upgraded to a redundant design. Option B. Implement a redundant network configuration for vMotion and storage vMotion traffic, ensuring multiple active network paths are available to prevent a single point of failure. Option C. Rely solely on existing asynchronous replication mechanisms to recover data in the event of a network outage affecting vMotion traffic. Option D. Increase the polling interval for vMotion network health checks to reduce the frequency of alerts related to network instability. The correct answer is B. Implement a redundant network configuration for vMotion and storage vMotion traffic, ensuring multiple active network paths are available to prevent a single point of failure. Explanation. The audit findings indicate a potential misconfiguration in the vSphere environment that could impact the availability and integrity of critical data. This scenario is professionally challenging because it requires a deep understanding of vSphere networking constructs and their implications for data protection and disaster recovery, without direct access to the production environment for immediate testing. The challenge lies in diagnosing the root cause based on indirect evidence and recommending a solution that aligns with best practices for data center virtualization and regulatory compliance, assuming a U.S. regulatory framework for this exam. The correct approach represents best professional practice because it directly addresses the potential vulnerability identified by the audit by proposing a solution that enhances network resilience and data accessibility. Implementing a redundant network path for vSphere vMotion and storage vMotion ensures that these critical operations can continue even if a primary network link fails. This aligns with general IT best practices for high availability and disaster recovery, which are often implicitly or explicitly required by various U.S. regulations concerning data integrity and business continuity, e.g., HIPAA for healthcare data, SOX for financial data, though specific regulations are not cited here due to exam constraints. This proactive measure minimizes downtime and data loss risk. An incorrect approach that involves disabling vMotion or storage vMotion entirely is professionally unacceptable. This would directly violate the principle of maintaining operational continuity and data accessibility. Such an action would create a single point of failure, significantly increasing the risk of data loss or extended downtime during maintenance or unexpected hardware failures. This failure to implement resilient network configurations would be a direct contravention of the implicit requirements for robust data center operations expected under most U.S. compliance frameworks. Another incorrect approach, such as relying solely on asynchronous replication without addressing the underlying network issue for critical vSphere operations, is also professionally unsound. While replication is a vital component of disaster recovery, it does not mitigate the immediate risks associated with network failures impacting live operations like vMotion. This approach fails to address the core problem identified by the audit, leaving the environment vulnerable to disruptions that could prevent successful replication or cause data corruption during the replication process itself. The professional reasoning process for this situation should involve 1. Thoroughly understanding the audit findings and their potential impact on data availability and integrity. 2. Correlating the findings with known vSphere best practices for networking, high availability, and disaster recovery. 3. Evaluating proposed solutions against the principles of minimizing downtime, preventing data loss, and ensuring operational resilience. 4. Prioritizing solutions that address the root cause of the identified vulnerability, while adhering to general IT governance principles that underpin regulatory compliance. Question 20. Compliance review shows that a critical application team has requested immediate network segmentation for a new development environment isolated from production systems. The proposed segmentation is a standard configuration that has been implemented successfully in other isolated environments. The virtualization administrator is under pressure to deploy this quickly to meet a project deadline. What is the most appropriate course of action for the virtualization administrator? Option A. Proceed with the network segmentation as requested, documenting the change in the change management system after deployment, and inform the security team of the completed change. Option B. Deploy the network segmentation using only the default security settings of the virtualization platform, assuming these are sufficient for a development environment. Option C. Implement the network segmentation immediately, as it is a standard configuration and the project deadline is critical, and address any potential security or compliance concerns later. Option D. Initiate a formal change request, including a detailed risk assessment and security review of the proposed network segmentation, and obtain necessary approvals before proceeding with the implementation. The correct answer is A. Proceed with the network segmentation as requested, documenting the change in the change management system after deployment, and inform the security team of the completed change. Explanation. Scenario analysis. This scenario presents a common challenge in data center virtualization environments where the need for rapid deployment and resource allocation can sometimes conflict with established security and compliance protocols. The challenge lies in balancing operational agility with the imperative to maintain a secure and compliant infrastructure, especially when dealing with sensitive data or regulated workloads. The pressure to deliver services quickly can lead to shortcuts that, while seemingly efficient in the short term, create significant long-term risks. The core difficulty is ensuring that all changes, even those perceived as minor or temporary, adhere to the organization's defined security policies and regulatory obligations. Correct approach analysis. The correct approach involves a thorough risk assessment and adherence to the established change management process, even for seemingly minor configurations. This aligns with best practices for data center virtualization security and compliance. Specifically, it upholds the principle of least privilege and ensures that any deviation from standard configurations is documented, justified, and approved through a formal process. This proactive stance minimizes the risk of introducing vulnerabilities or noncompliance. By requiring a security review and approval for the proposed network segmentation, the organization demonstrates a commitment to maintaining a secure posture and meeting any applicable regulatory requirements that mandate controlled network access and data segregation. This approach is crucial for preventing unauthorized access, data breaches, and potential regulatory penalties. Incorrect approach is analysis. Implementing the network segmentation without a formal security review and approval process represents a significant regulatory and ethical failure. It bypasses established controls designed to protect sensitive data and maintain compliance. This shortcut creates a direct vulnerability by allowing a change to be made without verifying its security implications, potentially exposing the environment to unauthorized access or misconfigurations that violate data protection regulations. Deploying the segmentation as a temporary measure and intending to formalize it later is also a failure. While the intent might be to expedite a process, the act of implementing a change that affects network security and data flow without proper authorization and documentation is inherently risky and non-compliant. This approach undermines the integrity of the change management process and creates an undocumented, potentially insecure state. It also fails to address the immediate compliance implications of the change. Relying solely on the virtualization platform's built-in security features without a specific review for this particular segmentation scenario is insufficient. While these features are important, they are not a substitute for a targeted risk assessment and approval process for specific configuration changes. Each change, especially one involving network segmentation, requires a deliberate evaluation to ensure it meets the organization's security policies and regulatory obligations, rather than assuming general platform capabilities are adequate for all scenarios. Professional reasoning. Professionals in data center virtualization must adopt a risk-based approach to change management. This involves understanding the potential impact of any proposed change on security, compliance, and operational stability. The decision-making process should prioritize adherence to established policies and regulatory frameworks. When faced with pressure to expedite a process, professionals should always advocate for following the defined procedures, even if it requires additional time. If the existing procedures are found to be overly burdensome or inefficient, the professional's responsibility is to propose improvements to those procedures, rather than circumventing them. This ensures that security and compliance are not compromised for the sake of speed. A robust change management process, coupled with a strong security review, forms the bedrock of a secure and compliant virtualized environment.